Hi, welcome to the Layer channel. So when you are learning about networking, whether it is in the case of generic networking for developing network software, or else in general about network internals, you must have heard about the Unicast, broadcast and multicast stuff, and these things do exist in the case of L3 context, in the sense like network layer, as well as it do exist in the case of layer 2 context as well, in the sense like data link layer. So there's a difference between layer 2 broadcast and multicast, and as well there's a difference between layer 3 multicast and broadcast and unicast. So when it comes about unicast, whenever you get typically any service packets, which means you open a website, you get any traffic, these are sort of unicast packets, because the data is going from your system all the way to some remote server or some remote device. Okay, sometimes your system may act as a server and that may act as a client, and it doesn't matter. And it can happen when you chat with your friend in Skype or Google Hangouts, whatever it is. So these things are more like unicast packets. So this is from an IP to another IP, but also sometimes you may have same way you may have all these packets will boil down with respect to layer 2 unicasts as well. So sometimes whenever you send a data to a new system, it doesn't know what is its MAC ID is, so naturally it has to send an ARP request, and once the ARP is served, once it learns the same in the ARP table, so you can see here in my system, if I print ARP, so it is going to print this ARP table. So you can ignore about this few entries, which is this 0T and other stuff. So these are coming from a special interface or a driver, which you can ignore the same. Other than that, you can see here it has this my Xiaomi router, and this is the MAC ID for the same. And if there are more systems I have connected in my home system, and in case if I have accessed it, then I may get some more entries over here. So this is going to tell that your L2 resolution, and then with respect to that, what is its connected IP address sort of. Okay, so this is what you get as a part of your ARP requests. So with this, when you do ping to some unknown IP address, and simultaneously, let's just open a Wireshark. So we open a Wireshark interface. Yeah, see, we have opened the Wireshark, and sometimes you should understand, sometimes as a sort of confirmation it may send ARP packets, and these are the packets which are going to be even unique as even an ARP request as well. Okay, if it has already learned, it will send like a confirmation, so that it still learns that it is in the same MAC address or not. So sometimes ARP requests will be unicasts, and most of the times ARP request packets will be in broadcasts. Okay, so that is what. So we open the capture, and in case if I come back here and I ping it to my Xiaomi router, ping 192.168.0.1, so that's my router or the gateway address. So I'm pinging the same. So if you come here, you can see the packets. I'll stop this capture. You can see here you have this ping, and before that you have this ARP packets. As I said here, it is already a well-known MAC address, so it is sending as unicasts only, but it is confirming whether it is true or not. So it has sent an ARP request from my system. You can see here from 192.168.0.88 to 192.168.0.1. So it is a pure unicast in terms of layer 2 context. Since ARP doesn't have any L3 header or IPv4 header, it is not going to contain the same. So it is a sort of a special packet where you don't have that service type of packets. So whenever you think about any data which is sending some files, receiving files, and doing the real job, we can call them as service network data packets or something like that. So it is not purely defined, you can generally say. And whenever you send any control packets like your STP or dynamic routing protocols, all these are control packets. Okay, they are not a service packet. Okay, they don't carry anything meant for end-to-end communication. They just send data meant for in terms of communicating device control and other stuff. So they don't carry any other data like user data or something. Okay, so this is the difference. So you can see here it is a layer 2 unicast, and its reply is also obviously layer 2 unicast. And if you want broadcast, you can do one thing. You can send an ping request to some unknown machine like this. So there is no system in my home which has this IP address. So when you do that, it is going to send an ARP request, and it is going to send some couple of times, and then it is going to fail eventually. Okay, so you can see there it shows a destination host unreachable or whatever it is. So you go back to Wireshark. Let us stop this capture. You can see here it has sent this broadcast. So it is a layer 2 broadcast. It is not a layer 3 broadcast. So anytime if you get layer 3 broadcast, it happens in the IP header IP address level. Okay, so that is completely different versus this is completely different. So this is a layer 2 broadcast. You can see here the destination is a layer 2 broadcast, and the source is layer 2 unicast. So it is going from this system which has this MAC address. This is having a inbuilt NIC card, which is a motherboard NIC card. So it shows the OUI identifier. It shows it is from Gigabyte motherboard manufacturer, and it shows whatever the serial number. So 98CB66 is like its serial number, and the initial 3 bytes is like an ID to represent it is from which company. Sometimes it may show Intel, Cisco, whatever it is, whichever is the manufacturer. In case if I use this my other NIC card, like in my case I have this NIC card. Okay, so this is a USB to Ethernet 1 gig NIC card, USB 3 to 1 gig Ethernet NIC card. In case if I use it may show some other MAC address, and if you check its OUI in the internet, it will show who could be its manufacturer in case it is registered. Okay, so let me just plug this NIC card. I sometimes use this for some experimentation purposes. I took it for my lab, meant for some customer work, and of course he paid for the same. I have not purchased. Okay, so you can see here it shows up that newly plugged in NIC card. It is not connected to any wire. So let's take this and we can do a OUI lookup. MAC address OUI lookup. You can find some websites like this. Okay, so it will connect to some remote database, and it will show it's a vendor. So you can see here it shows as some goodwill in co.limited or something. So some type of vendor. So that time it is a sort of a niche market. Getting a 1 gig NIC card is quite hard. I paid a sort of premium price for this. I think I paid around $50 equivalent of Indian rupees, so which is around 3,000 rupees or something at that point of time. I'm saying around 2014-15 duration, and that time even USB 3 is quite niche in the industry, so it's quite rare at that point of time. I need to go and find it out, source that part, whatever I need for that experiment, because I need a dual gig NIC card for my laptop for some type of tests. So this way you can find, so that is what even Wireshark shows over here. So in case if you are new, these things you can try and you can learn about it. So it's a unicast and it is sending to a broadcast. So it is a layer 2 broadcast which happens. So next you can also learn about in the books, you must have learned about multicast, and this is where the confusion starts. And the main intent of shooting this episode is all about covering a layer 2 multicast, because this is where some type of magic happens, which is not everybody can understand, and it needs some type of an expert who has some hands-on to explain really what this multicast is all about. Okay, so multicast packets are mostly used for communicating control data. It is not meant for any service data, which meant a data like this. See, you have this UDP packets and you have some TCP packets. If I open this website or something, it may communicate TCP, SSL data and other stuff. So it's not meant for that. Okay, it is meant for some type of control level data. And yeah, if you learn networking as step by step, you will eventually understand. Okay, and So when you have network switches, they may have this STP protocol and they may communicate in multicast addressing, and you may have some type of layer 2 protocols, slow protocols. We call it as slow protocols because these protocols are not meant to pump a lot of data. It has to work once in a while, and it should send some type of control data. I can't explain more in case if you are new, so which is why I'm trying to cut down so that you understand the overall big picture. Okay, so it may send some control data, but it should not flood that network. Okay, so it should send as less as possible, as infrequent as possible. It should not send too frequent, so it should be working at regular intervals, which is why we call it as slow protocols in the industry. So if you Google about layer 2 multicast, L2 multicast address or something, you can find it some type of Wikipedia reference. So I was discussing this about in this couple of weekends with a couple of students, which is when I thought it's good, interesting to cover some type of video episode, so that it may not so elaborate like I cover with my students, but I can give a sort of a quick overview what is this overall stuff is about. So if you buy any manageable switch or some type of expensive Cisco switch which has VLAN and other stuff, and in case if you also turn its STP and other capabilities, then you will find this in the network. And in case if you cannot find this in your home network, I can suggest one thing is in your office you can capture some Wireshark packets, which is perfectly legal because they are meant to encrypt any type of sensitive data, and you are allowed to do that. Okay, no one is going to restrict you. So in an office you can if you are working in a corporate, you can capture some few packets, and then you can find these STP packets in your network. Okay, so that's what. So you can see here they have mentioned some V4 multicast address ranges over here. So other than that, you should also find a list of layer 2 multicast addresses. So these are pre-registered address series. So these are special addresses. What happens is, whenever you get a packet to the NIC card, if the NIC card, let's just take this NIC card as an example. So whenever you get a packet to this NIC card, let me connect this cable. See, when you get a packet to this NIC card, hope you can see here. So I have connected to this Ethernet cable. So let me just disconnect because it is quite short. So whenever you get a packet to this NIC card, it will have that firmware, and it will have its own unique MAC ID like what you have seen earlier. So if it gets a address which has that destination address, L2 destination address, so it will check its MAC ID to that. So if there is a match, then it's a unicast address. It is going to accept that frame. Okay, so it is going to accept that layer 2 frame, and it is going to pass all the way to the operating system or the software layer through device drivers. Okay. But if it gets any broadcast, okay, what it does is it is going to anyway accept and send it to the software layer again. Okay, and if it is getting any wrong MAC ID which is not matched with this MAC ID, then it is going to just drop it in the NIC card itself, which is very important feature, because if the NIC card start accepting all this junk data, then you need to filter it out in the OS level or the software level, and it is an unfortunate situation. This thing happens anytime you enable promiscuous mode in your port, and if you enable promiscuous mode, it will get all the packets which is not even meant for this, and it is going to flood your OS layer, okay, the software layer, and the software layer has the burden to sort this, and then it has to drop that. Okay, so this is the reason this thing has that type of a feature in the firmware, so that this acts like a gatekeeper. Even before someone comes and knocks your door, it is like you are keeping a gatekeeper, and he may respond to some people, who comes, and in case if someone is coming for door-to-door marketing, he may send them out from there itself. They don't come and end of the day knock your door. So this acts like a sort of a watchman or a gatekeeper, okay, the firmware inside the NIC card. So anytime you get unicast, layer 2 unicast frames to this NIC card, if it is not matching to this NIC card MAC ID, it is going to simply drop them in the hardware itself. Okay, so even the operating system cannot see this action unless until you enable the promiscuous mode, then all these frames is going to come to the software level layer, okay, and then you can analyze them, okay. So this is what it happens. So this happens with the firmware, whatever they put inside any NIC card you buy. So in the case of multicast, it is a special multicast address. So whenever such multicast addresses comes, don't confuse, they are not unicast addresses. These ones are pre-registered multicast address series. You can see here everything has a purpose. One is STP and one is Cisco shared STP address. So it is some type of proprietary version maybe, okay. So the other one is CDP and other stuff. And you have this OAM. This is something which I have worked when I was working long back, and so on. So these are various slow protocol, MAC IDs or layer 2 multicast addresses. So we call as slow protocol, or we call as layer 2 multicast or slow protocols, whatever. It is all used in any combination, okay. So this is what it happens. So whenever such unique packet comes, then this NIC card will accept, and then it is going to process. Sometimes you may have a layer 2 switch which is manageable switch, and it is sending this STP, and STP is used to avoid broadcast ROMs, to avoid loops. If you're a bit more, dig down, you will learn. You can Google and learn, or else sometime I may take one video episode about an STP. So let's not go somewhere in this episode. Let's focus about this unicast, broadcast and multicast context. So you are clear about the broadcast. Broadcast is just FFFs. You can see here. Okay, so you imagine anytime such address comes, so the NIC card is going to do simple task, okay. It is going to do an AND operation, all the Fs and its internal MAC address, and it is going to get back again the same address, and then it is going to accept that particular frame, and it is going to pass to the software layer. So that is why anytime you get those FFFs, okay, which is going to match any sort of packet. So anytime you get a broadcast, a NIC card do an AND operation with its own MAC address, and it is a broadcast, so it is going to accept. So this is what happens, which is the reason when you need to restrict this broadcast domain, so you need to use this a router, so that you can prevent excessive broadcasts, so that it is not congesting your local area networks. And people who are confused, these layer 2 broadcasts only happens within a specific LAN segments. This is not going to travel all the way to internet, okay. So don't get confused. The router is going to isolate this layer 2 broadcasts. Each connection, a hop within the router, again there is going to be a broadcast domain going to exist. So let's not again go much in depth. You have something called as collision domain, you have something called as broadcast domain, and stuff like that. So again, you can Google, or I have long back ones covered. You can search somewhere and you can find those videos. So this is what it happens. So this is why it is a sort of very special address, which looks like this unicast address, but it is not. It is a multicast address, and it is a pre-registered set of multicast addresses. So what I can do is, since in case if you are learning from home, maybe perhaps you may not have any sample, so we can do one thing. You can go to Wireshark sample captures, Wireshark, sample captures, and then you can download any such frames, sample captures, and then you can open, and then you can study the same. In case if you are even more curious, you can generate your own packets through raw sockets. Once I did some series on raw sockets. Okay, you can see here I have done a series of video episodes on raw sockets. These are done quite long back, so don't expect any sort of video quality like what I shoot these days. So if you go here, I did some few examples. This is Google Quick protocol packets, which like a SSL which runs on top of UDP. So this is one example below, which you can see here. You have this WIFE SIP packets. These are SIP packets on UDP, of course. So SIP is an application layer protocol sort of. And then you have this STP packets, and below that I have even covered some OSPF. I believe OSPF is layer 2, or No, it is on v4. You can see here it is not a layer 2 flow protocol, so it is on v4, which is understood because these dynamic routing protocols are all IP based, okay, whether it is SIP or whatever it is. So OSPF cannot be a layer 2 slow protocol, but little bit you move up, you can see here STP protocol is a layer 2 slow protocol. So we can do one thing is we can you can download and you can compile. I have already something like this downloaded, which I have once in a while discuss with my students. So CD raw sockets. Yeah, I think it is not in this folder. Let me just download the same. This is the code which you can download it, and we can compile and we can run the same. Yeah, raw sockets we just save here, and it doesn't have any sort of protection code. So in case if you get any segmentation fault, please note you are missing some port number or something. And moreover, raw sockets, whenever you give, you need to give that exclusive access, so you need to give that root permission. Okay, so gcc -o stp.c, so that should compile the same, and sudo /stp eno1. so that's my Ethernet port, and please note this I have disconnected. It is actually currently with me, so no longer this port exists in my system. Okay, we do the same, and before that we can start a Wireshark capture once again, and we run this. Yep, let me provide the password. Yeah, you can see somewhere it should send this HTTP packet. So let's just sort it out. It should be inside this actually. So yeah, you can see this is not the one, by the way. This is some IGMP v2, and here you can see here it shows something like multicast. I'm not sure what this is. Anyway, this is not the thing which we are looking for. You can see here STP is come. This is coming from that code, okay, not that IGMP. I was just seeing what could be it. So you can see here, this is the layer 2 slow protocol. This is how it comes, and moreover, its intent is not to flood the network. So that is the reason you have to call them as slow protocols, because these are very important control packets which are often layer 2 based. So okay, so this is why we call as layer 2 slow protocols. Okay, so you can see here it's a STP packet, and STP frame. Okay, and you can see here its a source is whatever I have hard coded. By the way, see here the code. I don't want to do full walkthrough, but you can see the code I have hard coded, and the first 6 bytes is its a multicast address. So you can see here the destination is a multicast address, and it has that same byte combination 0180C2 and 000. Okay, which you will find the same thing in this Wikipedia. Okay, of this registered multicast addresses. Okay, so this is like a sample packet. I have a sample packet, and then I have written a raw socket by extracting the bytes, and then I have just did a hard coding of that array. As you can see here, this is the code. I have just hard coded this raw bytes. So let us go here. Yeah, you can see here I just hard coded the array, and I'm just dumping on the wire. So this is enough to generate any packet. So you can create through raw sockets, you can create any malformated packets. You can create your own layer 2 protocol, your own layer 3 protocol, layer 4 protocol. You can write any protocols of your choice, and through promiscuous mode you can get any frames, and then you can write your own layer 2 stack, and then all the way up. So there is no restriction. So sky is the limit. You can do any type of experimentation with this. So raw sockets is quite important if you are a network programmer or even a researcher. Especially you need to write your own protocols, then you can use raw sockets. Okay, so this is one thing. So hope this shows that idea, and here also you can search STP like I mentioned. Okay, if you are not getting my code just has one packet or one template, you can go here and download an STP sample. You can see here there is an STP pcap. Just download the same, and you can open in Wireshark. You can see you can get tons and tons of packets here, and you can get any type of example. Okay, And if you open, you can see here it has the same 0180C2000 in hex multicast address, layer 2 multicast address, destination multicast address. So which is what, and you can see here it has all this spanning tree protocol stuff. Okay, so let's not get into the spanning tree part. The objective is not about how STP works. The objective was all about what is a slow protocol, and moreover how this multicast happens in the real world, because this is something they do little bit of goof up in the college books. They generally tell multicast is meant for few people, broadcast is for everyone, unicast is for single person. It is not a real example. Okay, this is the real example. In the action, this is what it is. Okay, so these are all multicast, layer 2 multicast frames, versus you can see here these are simple TCP packets. These are all simple unicast, layer 2 unicast, and as well as L3 unicast as well. So it has a specific source address, it has a specific destination address, and it has an address which matches this computer with some remote computer, whether it is in the internet or you ping to your router or to your smartphone, whatever it is, it should match. Okay, so these are very simple unicast packets. Unicast IPv4 or L3 as well as unicast layer 2 as well. So these are simple packets, but when it comes to those special cases, you need to do something like that so that you will understand where it happens. And in case if you are working in a corporate, you can anyway capture and then you can segregate any interesting packets in case if you stumble, and then you can learn about, you can see further some examples in Wireshark capture, and then you can learn. And here you can dig down and you can find various other samples as well. See, you can have multicast, you have this Ethernet OEM, you can search any example Ethernet OEM. Like I said, I have once worked in Ethernet OEM stack. At that point of time, even Wireshark had an issue because the standard is quite new. I'm not finding it here. I'm not sure whether it contains, no, there is no Ethernet OEM, I believe. Okay, so, or else let me search as 802.1q or OEM 802.3h. Let us search this in case if they have mentioned the same. No, it doesn't have the same, so we can just ignore. So there are several layer 2 slow protocols. Anyway, if you little dig down, you can find something which matches, and if not in Wireshark sample captures, in packet life you should able to find it out. Okay, so somewhere here you can find the test captures, and you can jump onto some layer 2 part. You can see here switching part, and here somewhere you can find what you are looking for. So 802.1q tunneling, let's open if something matches. No, this looks like a unicast. It is between some type of tunneling between a Cisco to Cisco device. This is not the one, and it's a complete V4 packet. As you can see here, it has entire V4. Yeah, this is, I think, VLAN stuff. Yeah, 802.1q is just a VLAN. Okay, it is some type of VLAN trunking. Yeah, you can see here they have mentioned the same tunneling. It's like a sort of VLAN frame with V4 within the same. Okay, so I hope this gives a sort of overview. I of course discuss more in depth when I do sessions with my students, but I feel this is an interesting topic. In case if anyone is a beginner, for them they will be highly confused about this multicast, unicast and broadcast stuff. So what I have covered is a layer 2 aspect. It is not about a layer 3 aspect, so don't get confused about the layer 3 aspect. That itself is a complete different world. So sometime later I may cover about the layer 3 aspect, but to an extent, if you see the layer 3 part, you can already see visibly over here. These are a specific IPv4 to IPv4, so these are unicast packets. And when you have some type of streaming or something like that, sometimes you may get this multicast L3 multicast packets, like they have mentioned over here in the Wikipedia. You can see here, if you go a little bit up, you can see the list of IP multicast addresses. So some are meant for something. You can see, yeah, OSPF is a multicast address, IPv4 multicast address. I believe my raw socket code has that multicast address. See, this is the OSPF, and it should have a L3 multicast somewhere here inside. So you can see here I'm just adding this stuff. I have hard coded inet underscore address, so that is a L3 multicast. So this is what, so this is a L3 multicast. And broadcast, yeah, it is again straightforward. If you replace with everything with 255, that is going to be your broadcast. So which is why if you see any NIC card, if you do ifconfig, you have this net mask and you have this network broadcasts. Okay, so which is simple. You have this subnet 192.168.0/0. That's my subnet, because if you do an AND operation with the net mask, it is 255.255.255.0. It is 192.168.0.0. And if you do any AND operation between this broadcast and net mask, you should get the network ID. So this itself is a complete different topic. This is all about subnetting, supernetting, CIDR stuff. Okay, so I think we'll discuss sometime later. This is something you find very common in CCNA books, and I feel sometimes not to prioritize that topic as well. So it's more interesting you learn this, V4 and as well as L2, unicast broadcast stuff, because this is where the confusion starts, and this is something very basic, but still people are a bit confused. So with this I would like to conclude this episode. If you have anything to discuss, be in touch via YouTube comments, or you can be in touch via mail. Thanks a lot for joining me. Stay tuned. Have a nice day. Bye bye.